So we're kind of in the middle of chapter 1 here. We're on section 1.14. We're going to talk about bonding in organic compounds. So these are illustrations of the shapes of the s and p orbitals for an atom. And we learned about this in general chemistry. When a bond occurs, we have overlap between the orbitals of two separate atoms. And you can imagine these atoms getting closer and closer, and their orbitals will overlap. When those orbitals overlap, they form a bond, and that's what holds the two atoms together. This is now considered a molecular orbital, and it is different than what was present in the individual atoms. There are two basic kinds of bonds when we think of orbital overlap. A sigma bond is symmetrical. It lies along the axis of the two bonded atoms. So when we get these two s orbitals overlapping, we get a bond. The axis of the two bonded atoms is a straight line between the nucleus of this hydrogen and the nucleus of the other hydrogen. And if we were to look down this bond, we would see that it was symmetrical. So I think of S sigma for symmetrical. So if this was one hydrogen atom and we're looking down, you can see why I didn't go into art. If we're looking down the axis between the two atoms, the bond is symmetrical. It's the same, it's round. That's a sigma orbital. And these are a sigma bond. These sigma bonds can form between two s orbitals, as we have here. They can form between two p orbitals. The p orbitals have this lobe shape. And when this lobe overlaps with that one, it forms a bond here. That bond is symmetrical along this axis. We can also have overlap between one p orbital and one s orbital. And this gives us a ps sigma bond. And it's that overlap. Any questions? So we're taking these atomic orbitals and we're overlapping them to form these bonds. We're not going to talk about this very much until chapter 3, but if you can have another kind called a pi bond, and what happens here is you have two p orbitals, but instead of overlapping end to end, they overlap side to side. So they overlap here. Now, if you're looking down this way from here, from one nucleus to the next nucleus, what you're going to see is something like this. There's a nucleus, and the bond is going to be up here and down here because of the overlap between those two p orbitals. That is not symmetrical. It's not a cylinder like the sigma bond was. So we'll get to more on that later.